Hello guys. So this is not my usual tutorial. I've been asked to make the or remake Stylized foam tutorial I made 2 years ago, and like people complain lots on the audio quality, and I thought that's like okay, I'll try make another one. So I was doodling around with the water shader and end up with the result that you saw from the demo. So this one is more like the proof of concept. I've been playing Octopus Traveler and Motor Shell nearly, so that's where I had my inspiration from. I'd like to have this nearly clear water with some foggy sheets over it, with small little details, not heavy normals and so on. So yeah, it reminds me of something realistic and surrealistic. It's like the combination of those two definitions. So the water. It contains of several features. We have the shoreline, we have the foam, we have the highlights to simulate the shimmering effect from the sunlight. Normals are actually procedurally generated from the noise, and all this shader doesn't have any texture at all. It's all done with the adjustments over the procedural noise node, and that's why it has so many instructions, so like nearly 2,000 instructions. So I won't recommend this one to be used as the end product. The reason why I use noise here is to get the proper pattern that I like, and then you probably change the noise nodes to the texture or to bake the result that you received from this one. I also have the tutorial. It's called channel packing, so you can check it on YouTube and know how to bake the noise. And here I also have the reactive component that I used to make for my reactive water. So to get this one, you need to be the subscriber for my Patreon. And yeah, we have opacity, roughness, combination of colors, and so on. So to start with, I need to tell you that Shoreline here is created with the mesh distance field. So to get the proper results, you probably need to switch off the lumen because it has some heavy artifacts on the edges of the mesh distance field, and use screen space resolution reflections. So this water shader. We start with this setup from the details panel. It's translucent water. I use material attributes, so my final mixture looks tidy and clean. I also use lots of named reroute nodes here. And one more thing here is that for the foam, normals, and the highlight base, highlight logic, you may see that the pattern, the logic that I use, is the same. Difference is those vector 4 nodes, the adjustments attributes. So you may use this one as the material function, and your graph will also look tidy and cleaner. So besides this one, I switch off tangent space normal because I need this one to work better with the procedural normals. Here I'm going to explain it a little bit later. Also what? I have screen space reflections. I have apply fogging and compute fog per pixel because the water is calm, and that's why this gets more instructions, but the results is better. Lighting mode is surface translucency volume, so I can use the roughness and refraction. I use translucency pass before DAF, so that's why I have the nice looking bokeh effects over the water. And I use refraction mode as the pixel normal offset, so I can get the refraction as the static attribute. So this one is the physically based correct refraction coefficient, and that's how the water has this kind of proper reflections. Yeah. So with this done, I also need to tell you that you need to so to have the proper shoreline, first of all, each of your meshes on your scene, I'm talking about the static mesh actors, should have checked the checkbox which is called effect. Let me show you. This one, effect distance field lighting. If you don't have this one, then your mesh won't generate the mesh distance field. Obviously, you won't have the shoreline with your water. And you need to switch it off in case you don't want to have this one, like for the floor that I have underneath my water, and so on. So next, let's talk about the shoreline first. We need to have distance to nearest surface divided by the attributes. My vector 4 nodes here have the custom names for each channel: size, speed, waves number, hardness, and I penned RGB with the alpha, so I can extract each channel and use to have more control over the whole logic here. So I do the same here and here, because if I get this one, it won't get me the alpha channel. So this one will return the mesh distance field mask. So I can simply extract this one to the base color, and you may see how the mask looks in space representation. Next thing, we need to add the moving parts for our shoreline, so I use time and multiply it by G channel, which here is for the speed. I add it to our mask, then multiply it by the number and use the sine node, so this one will create the waves. I also need to clamp everything with the max which goes for this mask, and if I do this one, I also need to switch off the shoreline noise so you can see what I have, and this one will get us this basic shoreline effect. If I actually switch off the refraction, you may see that those lines aren't changed at all, like this. So that's the basic shoreline. So if I have refraction here with the pixel normal offset here, even this one without the noise calculations here may lead to the proper shoreline distracted view. This one. and the higher normal power, the power of the normal map that we use or generate here, and the refraction coefficient, it will get more distractions for the shoreline mask. So why I use shoreline noise here is to get, the reason is obvious, I want to get more fancy results, more surrealistic results. So that's what I have with my noise calculations. So to make this one, oh, I didn't say about the alpha channel. Alpha channel is here for the hardness or the transparency or opacity of the shoreline. So it's multiplied after all the calculations are done. Then I saturate it and have the shoreline tint effect just to colorize the shoreline. So let me show how the controls work here. So let's say the shoreline is 200 units. We have the speed 0.6. We have the waves like 4 or maybe like 1. And the hardness might be 0.08 or 1. And if we go with the shoreline noise, we can change the timing to be like 1, like 2, like 4, like 6, 16, and so on. So it depends heavily on how you combine or adjust all those values, all those attributes. So different results may be achieved. So I'm gonna change everything back to the normal. 2, 3.4. I guess it was 32. So yeah, back to normal. As for the noise, shoreline noise, here I don't use blue and alpha channel. I might use it for the future, but right now I only use the red and green channel. Red here is for the tiling of the noise, and green one is for the opacity or the hardness of the noise mask. Noise here have different settings that might be used for different purposes. Levels here define the low frequency noise on the edges of the base noise shape. So if you have 1, the noise pattern will be smooth. If it's 6, it might get more fluffy, like this. Output min and output max are for the black and white color, like for black and white color. So if we get with like 0.5 to 1, we get from the gray to white one. If the minimum will be 0, we start from the almost like from the low values of the black color inside the mask, and if we get with the max of, like instead of 1 to 0.1, we have the whites to be gray 1 and nearly to black. So those values define those bounds. Also, you may see that if we have like 0.5 on our max here and the minimum will be like -3, the amount of the black color will be higher. So if you know this one, you may get the proper pattern for each mask that you would like to add to this water shader. Turbulence here defines how low and high frequency noise are combined. So if this one is added, the more white color you will have and the pattern size will be smaller. If this one is unchecked, the results are opposite. So that's how it was previously. So to add the noise to the shoreline, we need to add it between the sign and the clamp nodes here. Next thing is the normals. Normals here have the similar setup as we have here. Like all the changes for the normals, for the form and the highlights is inside the noise nodes. So you may take a look how I have mine. So let's start with the normals. 0.5 to 1, levels 5. So I have slightly gray to the white to not get much details on the normal. For the foam I have from 0 to 0.1. So this foam, it's not like the foam, it's more like the fog effect over the water. And for the highlights it's -1 to 0, so I have a lot of white dots to simulate the shimmer from the sunlight. So logic essentially the same. UV multiplied by channel to get the scaling or the tiling. Add time multiplied by both vectors, so we have the speed and direction. Like if we change the speed from 0 to 1, we have one direction, from 1 to -1 opposite direction, and the size of this scalar defines the speed. So it's like 2-in-1 attribute. Append 0 and provide everything to the noise, so it may change all the settings. Multiply by alpha channel to have the flatness. And here comes the interesting part for the prepare per tube normal high quality. So this one, those two material functions come from the out of the box of the Unreal Engine, and they help us to change the white and black pattern to the normal map. So I don't know whether it show me the, yep, it will show me the normal that I have here. So what else? At the foam also the same, except that I need to add everything, saturate, so the values for the foam won't get higher than the 1, multiplied by tint, so I have this fog or the foam colorized a little bit with the color that I want, and it's everything goes like to the named reroute node. The same for the highlights, so everything is the same. The changes are only in those noise nodes. Also I use multiply by 8 here to have a little bit more harsh edges, not smooth but harsh edges for those little shiny dots over the water. Now let's talk about how to combine the color. So I have the main color here, I add highlight, saturated, so this one won't go to the higher than the 1, I add the foam, I add the shoreline, add everything and put it to the color, like this. So refraction will be done. As for the roughness and the opacity. Opacity here defined with the Fresnel, and if I combine it with the pixel normal old space, or with the, with what? Where I have this? Where I have my normals. With the normals here, they will be calculated and used for the opacity. So you'll have the opacity transparent at the bottom of your screen, so closer to your character, but it goes up to fully opaque on the edges. So you may see that here we have this transparency, those values on the edges on the top of our screen, we don't see anything, and it's much more appropriate, nice looking effect. So if you have the shimmering or translucency there, it might not look as good as it looks like right now. And for the roughness, I use opacity because this one can use as the alpha for lerping between 0 and 1. So we have the roughness and shimmering effect closer to our character, but fully rough. I mean, fully rough on the edges of our screen. So those values are probably they won't shine at all. So combine everything here, and this one is the bonus for those who are my Patreons. So if you have the reactive water, you can copy paste this one from the reactive water base shader and combine these normals with this one provided to normals, so you can get the reactive effect here where I walk and I have this wave spreading from my legs. So that's how this one is made. Also, lots of stuff defines on the scene setup. I mean, you need to have the proper setup for the post process, volume for the directional light, and so on to get more appropriate results. So if I launch the game, you may see that if you have the depth of field and the tilt shift effect, which is dynamic, the overall scene looks much better than it might look without this one. So with that, I guess that's it. So as always, guys, I hope you like my tutorial. Feel free to subscribe, to leave your feedback, press like button, and in case you want to support me and get all this magic, all this beautiful work done for you, you can subscribe to my Patreon. The link is under this video. And yep, see you soon, guys.